In Objective 4, we're looking at solving problems involving similar triangles. Two triangles are called similar if they have the same shape but different size. So looking at these two triangles right here, they are similar, and we're going to use that fact to show the fact that similar triangles are in proportion. Alright, so the corresponding sides right here are C and Z, B and U, and A and X. So if I look at those ratios, the ratio of C to Z is 3 to 6, or 1/2. The ratio of A to X is 6 to 12, or 1/2. And the ratio of B to Y is 7 to 14, or 1/2. So what we notice by looking at this example, in order for them to be similar triangles, the ratio of similar sides are always going to be equal. That's part of what it means to be similar triangles. Okay, so the lengths of corresponding sides to similar triangles are in proportion. Okay, they're in proportion because when you look at the two proportions of two different ratios of side lengths, the proportions are equal, so the sides of the triangle are in proportion. So in example 6, these two triangles are similar. 3 and x correspond, and so do 8 and 10. So I can set up a proportion here to solve for x. I know that the ratio of 3 to x is going to be the same as the ratio of 8 to 10. So I've set up a proportion, and I can solve that proportion by cross multiplying. Okay, so I'm going to multiply 3 times 10, and that is going to equal 8 times x. Okay, 3 times 10 is 30. 30 equals 8x divided by 8. And let's go ahead and get the decimal for that. 30 divided by 8 is 3.75. So for these two triangles to be in proportion, that missing side x is 3.75 yards. Okay. Alright, we've got two more triangles here that are in proportion. So 7 corresponds with 4, 8 corresponds with x. So our ratios are 7 to 4 equals 8 to x. Notice how when I set this up, I have large triangle across the top and small triangle across the bottom. We need to be consistent to make sure that our proportions are correct here. The large triangles across the top, the small triangles across the bottom, and we have the relationship for this proportion, 7 to 4 and 8 to x. Okay, and we'll cross multiply. 7 times x equals 4 times 8. Okay, 7 times x equals, I'm sorry, that was 4 times 8. 4 times 8 is 32, and then we'll divide both sides by 7. Let's go ahead and get a decimal for this as well. 32 divided by 7 is about, we'll say, 4.57. Okay. So in order to be in proportion, the triangle that has side length x right here, to be in proportion with the 7 and 8 triangle, it needs to be 4 and about 4.57 feet. Okay. And our last example here, find the height of a lookout tower, shown below, using the little tiny stick right here. So I've actually got two triangles, the large triangle and this inner triangle. Since it's inside the bigger one, I know they're in proportion with each other. So if I look at the tiny triangle, it's going to have a ratio of 2 over 3.5, comparing the height to the length. And if I compare that with the big triangle, the height of the big triangle is h, and the length of the big triangle is 56. Alright, so those are in proportion, so we'll solve by cross multiplying. 2 times 56 equals 3.5 times h. Alright, 2 times 56 is 112. and then we'll divide both sides by 3.5. So similar triangles can be used to measure tall objects. I mean, it's very hard to get a ruler or measuring tape up the side of a building, but I can use a tiny known measurement to create a similar triangle or a ratio that I can use to get that measurement. So 32. Okay, so that tower is 32 feet tall.